All right, kinematics, day 10. This is when we start to get into some problems, um, math type problems, or application problems rather. Most of you all seem to be doing pretty well with these already, but we'll still go through them all the same. Hence, as you've seen from the stopwatch type problems, it's helpful to start a problem by drawing a diagram. Otherwise, visualizing it can be kind of difficult. If you ever teach the lower level classes, the more important it is to draw diagrams because they haven't been quite to the point where they can visualize something in their head. Sometimes it's helpful to make a list of everything you know. I know if I tackle a problem well beyond my normal reach, I might write out everything that I know just to kind of think about it until I kind of tackle the problem. And identify what you're looking for. Now, I personally would never identify what I'm looking for because I usually know what I'm looking for, but it doesn't hurt to say, I'm looking for the acceleration or whatnot. So we'll do a couple problems here. Let's say we got a train. It covers 60 miles between 2 and 4 p.m. How fast is it moving at 3? So you got a couple choices, 15, 30, 60, etc. Your initial reaction is probably say 30 miles an hour. But one key note here is it doesn't say like words. Let me pull this up. It doesn't say words like constant or uniform or something to indicate that its speed is not changing. Therefore, it could have sped up, and slowed down all between there. So the reality is we just don't have enough information to solve said problem. Okay, next problem. Sloth is traveling with uniform motion, so now it says the word uniform, so now we know it's a constant speed. And it was at 10 centimeters at 2 seconds. If it's traveling at a speed of 10 centimeters a second, where was it at t equals 0? So we have one data point. Why do we keep going to eraser? Stop doing that. And that is at 10 centimeters. It is 2 seconds. We also know that delta x is equal to our average velocity times time. So we're kind of looking for delta x. So I take delta x is equal to 10 centimeters per second times. It'll be a period of 2 seconds, right? Because where was it at 0? So I'll put in my 2 seconds. Notice your seconds cancels, which only gives you a unit of centimeters. And so delta x is going to be 20 centimeters. Now, so you would look at this, and your first instinct is to say, okay, well, 10 plus 20 is going to be 30. But here's the problem. It said the word speed. Its speed, as I mentioned earlier, is not a vector. Speed could be in any direction. So, yeah, it could be 30, or it could be also at negative 10. Because we don't know what direction it was going. We just know it passed at 2 seconds going at 10 centimeters a second. And that's a speed, not a velocity. So the answer is actually going to be D, A or C. It'll have 2 answers. Or if I didn't offer that, it was not enough information to solve the problem. All right, so I gave you a homework question or a test question on Basil Borgar Tonus, otherwise known as Basil the Bulgar Slayer, one of history's worst people. So let's just keep up with that theme. We have Vlad the Impaler, which I probably don't need to tell you much about, is at milepost 3, traveling east at a constant 60 miles an hour, and Attila the Hun is at milepost 30, traveling west at a constant 75 miles an hour. When do they meet, and where do they meet? All right, so I'm going to kind of draw this out of hair. We've got 3 mile marker 3, so I'll just put 3 miles. And then we have 30 miles. We know that Vlad is going to the east, so. And then we know Attila. 2 T's, 1 L, 1 A. I may have spelled that wrong. We're going to call that spelled right. We'll go for that. Let's just do this because he's Attila the Hun, right? Now we can spell this correctly. We'll just put Hun there. And he's going at 75 miles an hour. Okay, so we know that these two distances are 27 miles apart, right? Yeah. All right, so if one, okay, let's just start with Vlad. So if I say delta x for Vlad, which I'll put a v there for, would be equal to the velocity of Vlad times the change in time. Well, I know that the if Vlad goes, I don't know, 5 miles, then the Tilla's going to go 27 minus 522. So what I can say is that the delta x for the Hun, I'll put h, must be equal to 27 miles minus whatever Vlad did, so delta xv. All right, well, then we also know that the Hun, delta x for the Hun, is going to be the velocity of the Hun, vh, times his change in time. And so, well, here's the problem. We have two unknowns. We need two equations. Well, I know that xh is going to be 27 minus xv, so I'll make a substitution there. 27 miles minus delta xv equals vh delta t. And we still don't know what delta xv is, but I do know it's equal to vv delta t, so I'll make one more substitution. 27 miles minus, and I'll put in parentheses to say, hey, I made a substitution, vv delta t equals vh delta t. And I can plug in my velocities here in a second. But yeah, now I have one unknown variable, and that's time. And so now I can plug in what I know and solve. So let's do that. So let's do 27 miles minus, the velocity of Vlad was 60. And it's best to always, I think I mentioned this earlier, but it's best to always write this as miles over an hour. So 27 miles minus 60 miles an hour delta t equals 75 miles an hour delta t. You need to get your delts to one side. Sounds like I'm talking about lifting. Deltas. 27 miles equals 60 plus 75, and 135 looks like. So 135 miles an hour delta t. Notice a couple things. Miles cancels out. That means your only unit left is an hour, which is what we want. We wanted a time in hours. So if I take 27 divided by 135 and my calculator, I get a time of 0.2. So the time is 0.2 hours. So if I want to figure out when they met, I probably want to get that in a form of minutes, at least. So if I take 0.2 hours, come back up here, and we know that there are 60 minutes in an hour, hours cancels, that gives me 12 minutes, right? So it'll be 2 plus 12, or 212. And it doesn't say AM or PM, so we'll just assume military time, 212. We're good. All right, so that gives me the when. Where do they meet? To figure out where they meet, I can plug it into any of my original equations. I can either plug it into delta x is equal to xh equals vh delta t, or xv is equal to vv delta t. I'm going to go with the vv, so I'll just say, okay, vv would be 60 miles an hour times 0.2 hours, and that's going to be 12 miles. And so they were, Vlad, remember, started at mile marker 3, so I'm just going to add 12 to that, and he's going to be at 15, oh, it's back, yay, 15 mile marker. And so the key here is you got two unknowns, you need two equations, and they differ in the distance. Okay, keeping up with our horrible people, Elizabeth Bathory, Hungarian Countess. Let's say a speeding car flies by Elizabeth Bathory traveling at a constant 90 miles an hour, and Elizabeth takes off after a speed of 10 seconds later, traveling at a constant 100 miles an hour. How far does Elizabeth travel in this pursuit? Okay, so this is like one of the problems we did in the last lab, and we know if that they catch each other, they must go the same distance. So we know I could say that delta x for my speeder S is going to be the velocity of my speeder times whatever time it took. And then for Elizabeth, it'll be delta x, and I really shouldn't have put s there, by the way, because it's all the same. I mean, I could if I wanted to, but it's not really that accurate. And whatever velocity Elizabeth was traveling, and it'll be delta t, but she took 10 seconds less to travel because she started 10 seconds later. So she's going to spend 10 seconds less on the road, so I'll put minus 10 seconds. Well, you know at this point that we can't have it in seconds, so let's convert that to hours. And that'll be 2.78 e negative 3 seconds. Sorry, yeah, hours. And then I wrote this e. Why did I write this weird e? What am I trying to do to you? E, it means times 10 to the. So every time you see e, you can say 2.78 times 10 to the negative third. It's just calculator language for exponent. It's what it's spitting out of me right now. So I always write in e's because it's a lot easier than writing times 10 to the. Anyways. Now I can set these two equations equal to each other. So that'll be Vs delta t equals Ve delta t minus 2.78 e negative 3 hours, plugging in actual numbers. Vs would be 90. 90 miles an hour delta t equals Elizabeth 100 miles an hour. And then delta t minus 2.78 e negative 3 hours. Distributing 90 miles an hour delta t equals 100 miles an hour delta t minus 0.278. And notice when I do hours times an hours, they'll end up canceling right here. And that's just going to give me it in miles. So I'll say 0.278 miles. Okay. Also notice that everybody has a mile in it, so I can cancel out the miles. So that leaves your only unit left is hours, which is what we want, because delta t is what we're solving for. So I moved my delta t to the other side, so that's going to be negative 10 per hour. I know that kind of it was weird the way I did that. Maybe I shouldn't have done it quite like that. And then that's equal to negative 0.278 with no units because the hour flips over to the other side. And then I put in 0.278, divide that by 10. And then I get, oh, forgot my delta t. Wow. It's still there. It was just being silent, kind of like a silent E in my name, Blake. Yeah. All right. Delta t is equal to 0.0278 hours. And so we want to know how far Elizabeth travels during this. It's specifically asking for Elizabeth, so I'm going to use Elizabeth's equation, which is right here. So delta x, and really I could use either one, but since it asks for Elizabeth, I'm going to use that one. And that's going to be 100 miles an hour times 0.0278 minus 2.78 times 10 to the negative third. These both have hours, which I forgot to put, sorry. Hours cancels, so I guess it was pointless anyways, but you get the picture. So alright, and then times that by 100, and I get roughly 2.5 miles. And they both went the same distance, but I'm just going to use the Elizabeth's equation because it asked for her specifically. So Elizabeth went 2.5 miles, and so did the speeding car. All right, that is it.